All right, so to launch the lesson today, we're doing percent of change. I want you to think about this. Even if you don't have a younger sibling, it's fine. But let's pretend that you get $10 a week for allowance, and your younger sibling gets $5 a week for allowance. And whoever you live with is like, okay, we're going to increase both of you $5 a week. So now you get $15 and your little sibling gets $10. How could you mathematically argue, not that you'd argue with your parents, but how could you mathematically prove that this actually is not fair? Okay, how could, no. Okay, I want you to talk to each other about this and discuss, and then I will call on someone. All right, so what the point is your little sibling's allowance doubled, correct? That is a 100% increase in the allowance. But your allowance, you only got a 50% increase in your allowance. So what should, if you wanted to say it would be fair, what should your new allowance be? $20. So this is percent of change that we're doing today. So this is why this is important. What you do is you compare the two amounts. So how much did it change? $5, correct? And then you divide that by the original amount. It's always the first number listed. So 5 divided by 5 is 1, but in percent world, that's 100%. So they got a 100% increase. But you, on the other hand, from 10 to 15, that's 5, and then 5 divided by 10 would be a 50% increase. So that's how you could maybe present your case, we should say. All right, let's take a look at your packet, well, it's really just a notes page. Would you like to pass those back, please? Yeah, thank you. All right, percent of change. There's notes on the board. There's also this packet. A percent of change is a ratio that compares the change in quantity to the original amount. If anyone's going to make a mistake, it's always dividing by the original amount, okay? It's not whichever number you choose, it's the first number listed in the problem. So for example, apparently in 1970, gas was $1.30, and in 2010 it went up to $2.95. So you subtract the two numbers to find the amount of change, that's your numerator. They got $1.65, and what you can't see is they divided it by $1.30 because that's the first number listed. That's the original amount. They got 1 27/100, which to change it easily to a percentage, you can just multiply by 100. And that gas increased, it had a 127% increase in price. So you always have to say whether it's an increase or a decrease. If the two numbers go up, it's an increase. If they go down, it's a decrease. So let's take a look. See, for example, in, let me use this one. In example 2, bless you. In example 2, it was $280 and it went down to $220. So the numbers went down, so that's a decrease. All right, so let's take a look at our two example problems. Do you see how it says it went from 10 to 13? Did those numbers go up or down? Up. So that's a percent of increase. So you'd write increase once we find our percent. So a very condensed way of writing this is you subtract the two numbers, how you would normally subtract two numbers, and you divide it by the first number listed in the problem, not the first number you list, the original amount. And then to easily change it to a percentage, once you have that number, multiply by 100, and you can see what you will get. Make sure after you hit 13, not that you have to do 13 minus 10 on a calculator, but once you subtract it, make sure if you're doing it on a calculator that you hit equals first. And so what is our percent of change there? Say it. 30% increase. You have to put increase or decrease. And one's not better than the other. Things that decrease are good. Things that increase, that could be a good thing as well. Letter B. The price of a radio was $20. It's now on sale for $15. What is the percent of change? So you still subtract how you would normally subtract. So that's if you want more detailed notes, subtract. So you'd have 20 minus 15, which I know everyone knows, but I'm just showing. Step 2, divide by the original. So we are going to have 5 divided by what? 20. You should get 25 hundredths, and then you multiply by 100 to change to a percent. Not that everyone needs to do that. Most of you could look at it and tell me that. So it's a 25% decrease. Are there any questions so far? No? All right. All right. Here is number 1 worked out.
Wait, can I put it up here?
No, I want you to work it out on the screen. Are you gonna talk to us?
You do 30 minus 24, then you divide it by the first number, which is 30, then you times it by 100.
And what do you get?
20% decrease.
Because the numbers went down. 20% decrease. Go ahead and write it down.
I need it.
Thank you. There you go.
So first you do 120, or
You can just put the
I'm
150 in
messing.
front of it. You can just put the 150 in it. Or scribble out.
okay.
There you go.
So you do that, and then that you. I don't know what I'm doing. I keep on thinking it's decreased, but it's not.
You subtract first. And you divide by the 126.
For some reason, I keep on doing it like that. I don't know.
Well, you have to subtract first, no matter what. You
So
always have to
it's
subtract.
24.
Mm-hmm. So
Then
24.
divided by 126. 0.19.
But you multiply by 100, so it's what percentage?
190.
Just multiply by 100.
19%.
Yes, 19%. And we're going to round to the nearest whole percent, not to the nearest 10. 19% increase.
I don't know what I'm doing.
All right. So your work for today is only 1 through 9 because no homework this week. You must round to the nearest whole percent if necessary. So I'm just going to use money as an example because everybody knows money. So like $31.60, $31.60, that would round to 32. We're not rounding to the nearest 10, we're rounding to the nearest whole number. Number 7, everyone look at number 7. You have to not just find his mistake, you also have to correct his mistake. And finally, in number 8, there's 4 numbers. You're only comparing 2 of them, right? You're only comparing 2 of those numbers, not all 4. So just don't forget to round, put increase or decrease, and then we will check it.